So I've been given the slight task of trying to explain why we age, so I hope you're not in any hurry to escape. Is it only 15 minutes I've got, Alan? Right, okay. I shall do my very best. So I think the first thing we need to decide is what is aging. And I'm hoping I'm going to convince you that it's not just putting another candle on your birthday cake each year. So what I want to say to you is perhaps a definition of aging that we can use. It's increasing frailty with time that reduces your ability to disease with stress and increases your chance of disease and death. So it's a very biological definition. I always say, think of it rather like a wonderful Rolls Royce. You polish it and you wax it every week, but if you happen to bang into a lamppost, it'll just fall apart. And that's what aging is for me. So, why are we doing all this aging research? Why is Arthritis Research UK, the Medical Research Council, putting money into understanding? Well, as that film told you, if all of these diseases, cancer, cardiovascular disease, Alzheimer's, arthritis, they're all caused by aging. What we do at the moment is we try to cure cancer. We do cancer research, we do heart disease research, Alzheimer's research. But if they're all caused by aging, why don't we just try to block aging? And you may say, well, Professor Lord, you're absolutely barking mad. How can you possibly stop aging? Well, the evidence is that we probably can, because we're starting to understand why we age. What are the processes that cause us to age? So, scientists over the years have decided that there are 9 key things that happen to your body with aging. And if you look at whatever cell there is in the body, it's pretty well the same thing that happens. And you can break it down into just a few key things. So first of all, there's a buildup of damage in your body. It might be damage to your proteins, it could be damage to your DNA, but it builds up over time. The second thing that happens is that you reduce your ability to replace any damage. Many of you will have heard of stem cells. Well, your stem cells don't function as well as you get older, so you can't replace the damaged cells. The other thing that happens is the cells that you've got, the damaged ones, sadly don't just go away. They sit there, and they're called senescent cells. And they don't just sit there doing nothing, they behave very badly. So they produce molecules, things called cytokines, which then cause damage to the rest of your body. Lastly, as you get older, you can't even handle the nutrients, so you take in your food every day, and your ability to use that food to build new muscles and bones is reduced as you get older. All of those things together mean that we age. And as we said, one of our interests is the musculoskeletal system, so if you take all of those things together, what happens? So you can look at any system in your body. So Malcolm's already shown you this, but we lose muscle with age. That means we can't replace it, so that lack of ability to replace muscle, that lack of ability to take proteins in our diet and build new muscle is gone. The consequence is you lose muscle. It's not as simple as that. The muscle just doesn't go. This clear stuff is fat tissue. So you get the muscle replaced by fat. So again, that's another consequence of aging. And all this in turn then leads to this frailty that I spoke about. The practicality is that you get older, your strength in your legs declines, whether this is males and this is females. And this red line here is the amount of strength you need to carry out activities of daily living, going up and down stairs, getting out of a chair. So as you get older and older, your strength declines, and it's harder to do those activities of daily living. Okay. The key thing is, it's wonderful, Professor Lord, knowing all of this, but is it preventable? Can all of your research do anything about it? And the answer is yes, we think it probably can. What we want to do is keep more older adults like this and less like this, so more able to deal with stress. So what's the evidence we can do that? And Professor Jackson already mentioned this to you. So in scientific techniques, we can take all of these different animals, and if we reduce the amount of calories that they eat every day by 25%, amazingly, they all live longer. They live about 25% longer. So whether you're here, whether you're a worm, or a fruit fly or a mouse. It works in all of these systems. And you're going to say to me, but Professor Lord, they're fruit flies and they're worms. This can't possibly have any effect in other higher animals. Well, no, it looks like it can. These are experiments in the US in macaque monkeys. And these monkeys are now 30 years old, which is the equivalent to about a 70-year-old human. And the monkey on the left here is the guy who's been allowed to eat as much as he likes. And I think you can see, you don't have to be a monkey expert, that this is an old monkey. Look, he's lost most of his hair. He's lost some of his muscle and bone, you can see. He's got this curvature of his spine. He's not looking very happy, is he? The guy on the right is the calorically restricted monkey. This is a spunky monkey. This is really happy with himself. Look at him, he's looking at you. He's not going to take any stick from you. This is a monkey that's really well on top of things. But the key thing is, look, what they've done, these scientists, is they've looked to see how many of these monkeys have age-related diseases. So they've looked at how many have got cancer or heart disease or diabetes or dementia. And by the time we're 30, the control group, who can eat as much as they like, less than 20% of them are disease-free. But the ones who've had the calorie intake reduced, 70% of them are still completely healthy. No cancer, no dementia, no heart disease. But you're going to say to me, Professor Lord, these are monkeys. This can't be true for human beings. Well, we don't know yet because those experiments have not been done, but we've got some clues. So, this is the island of Okinawa off the southern tip of Japan. And the Okinawan Japanese are very interesting. They have the highest number of centenarians in the world. And interestingly, what they do, if I can get this to work, is they eat less than most of the Japanese. They have this tradition that you should always leave the table hungry. You should leave some food on your plate. Their children eat 60% of the recommended calories, and adults 20% less than average. So they're calorically restricting themselves just by their normal behavior. So they live longer, but do they live healthier? Well, yes, they do. Compared to Americans, Okinawan Japanese, 75% more likely to retain their cognition. They have less dementia. 80% fewer breast and prostate cancers. 50% fewer ovarian and colon. 50% fewer hip fractures and fewer heart attacks. These are very healthy people. So it looks like it works in humans as well. But what about other lifestyle behaviours? You can say, well, I might live to be 120 if I calorically restrict, but I wouldn't want to. I mean, do you really want to eat that much less? So what else could we do to keep in this state? Well, the other thing we could think about, the other key lifestyle, is physical activity. And we know that, unfortunately, physical activity declines with age. So this white bar is inactive people, and the older you get, there are more people who are inactive and less people who are active. We know also that if you take healthy young people and you make them less active, so you make them do less activity just for 2 weeks, then some at the back may not see it, but essentially in just 2 weeks, you lose 1 kilo of muscle. So you can mimic aging by just even making young people inactive. If you're old, it's twice as much. You use 2 kilos. So you can imagine an older adult, you end up in hospital for any reason, you know, even that inactivity, you're going to lose your muscle. So we know that inactivity is not good. So what we asked was, what about if we managed to find a group of adults that have been physically active all their lives? Perhaps is aging prevented? So what we did was we worked with this group of cyclists, and we had 125 of them. And they've cycled all of their life. They're in a club called Audax, so we knew they weren't telling us lies when they said they'd been active all their life. We had 84 men and 41 females, aged 55 to 79. And the males have to be able to cycle 100 kilometres in under 6.5 hours and 60 kilometres in 5.5 for the females. And they must do that at least twice every 3 weeks. And basically, we looked at these guys and we measured everything. They came into the lab, they spent 3 days with us. We made their heart, their brain, their muscles, their bones, their immune system. You name it, we measured it. What happened? Well, if we looked at their physical characteristics, so this is the percentage of fat they've got in their body, from 55 to 70 plus, no change. They did not have more fat. Fat-free mass, that's muscle. They did not lose muscle in the males or the females. So they didn't have this sarcopenia. They didn't have that increased fat. So that actually might all be due to the fact that we're less active as we get older. When we looked at strength, this didn't change. So timed up and go, the time that it takes them to get out of the chair didn't change over age. Some of their grip strength went down a little bit, but not stunning. So they had good function as well. It went beyond the musculoskeletal system. So I'm actually an immunologist. I'm interested in immunity. This is an organ called the thymus, and it makes your immune cells. And as you get older, it shrinks. So there's a young thymus, there's an old thymus. And it's really important because you need a big thymus to be able to help you have a good vaccination response. So we wondered, well, with these cyclists, if their muscles are healthier, what about other things? So we looked at the thymus. And here we've measured the amount of cells that your thymus make, your immune cells. There's the young person, there's the average, there's the old person. So these are the non-exercisers. These are just the people we pulled in off the street in Birmingham. And these are the cyclists. Look, they're the same as the young people. So their immune system was also better with exercise. So I'm just going to finish. If we're going to have 4 tips for staying healthy in old age. This is a study from Cambridge where they looked at just 4 health behaviours. Being a smoker, being a non-smoker, only taking moderate alcohol, being physically active, and having your 5 portions of fruit and veg. And basically, you get 1 point for each of those, so add it up in your head now. If you've got all 4, you do all 4 of those, you gain another 14 years of good health. So is that a good message or what? Thank you.